Okay, so we're going to be starting something new, which is the fundamental counting principle. And you've seen this pretty often, even if you haven't really thought about it. We're going to go into detail with it a little bit today. So with every new unit, we kind of talk about some new vocabulary. So the first term that we're going to talk about is the experiment. And this is the same thing as saying that when we flip a coin, let's say that we know that there's more than one outcome. There's more than one possibility that we could get heads or tails, right? So where an outcome is uncertain. Same thing as rolling a dice that or a die or more than one dice. Just knowing that you could get 1, 2, 3, 4, 5, or 6 for your answer if you rolled it once. And then the second term is the outcome itself. And this is basically just saying that whatever you get is the result of the experiment. So you flip the coin, you're either going to get heads or tails. The third term that we're talking about is a sample space. And this is just the set of all possible outcomes, right? And this looks a little differently. It kind of sounds like the same thing as an outcome, but it's going to be a little different. So when we say sample space, that's the set of all outcomes. So let's say we're looking at the integers from 1 through 9. So the outcomes, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. For the sample space, we would use curly brackets, and we would have to write that the set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are the same thing, but we need to remember they're not the same thing, but we need to remember to include curly brackets when we're talking about the sample space, which is the entire set. And then the last term that we are going to talk about is an event. And the event is any subset of the sample space. So let's look at our sample space up above. So any subset of sample space. So let's look at the integers from 1 to 9. So if we look above from the set from 1 through 9, if we were to only talk about positive numbers, right? Or even numbers, I'm sorry. Even numbers. From S is equal to, from this set of 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would only give us 2, 4, 6, and 8 as the event, right? So just taking out part of that. So we could even do odd numbers, and that would leave us with 1, 3, 5, 7, and 9. Multiples of 2, right? So 2, 4, 6, and 8, right? Same thing as even. Now let's take a look at an example for this. So one example is when we have we're trying to figure out how many combinations of meals we can make. So we have 3 different sandwiches. We have a turkey sandwich, we have PB&J, and we have a hot dog. Which is, according to a lot of my classes, this is considered a sandwich. We can continue to debate about this, so I thought this would be really interesting to throw in here. So we have 1, 2, 3 options for the entree or sandwich or main part of the meal, and then we have 3 different sides. So we have chips, fries, and a salad. All right, so 1, 2, 3. We also have 3 different drinks. We have water, soda, and juice. 1, 2, 3. So we want to figure out how many combinations we can make here. So what we can do, so this is just one example, I'm not going to write them all out. We would write turkey. You can get chips, fries, and a salad from that. And from chips, you can have one of 3 drinks, right? So you can have water, soda, or juice. And then you would do this for this for fries as well, and you would get the same thing: water, soda, juice. Same thing for your salad: water, soda, juice. And if we were to write this out for PB&J and hot dogs and do the exact same thing, we would see that we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities just from a turkey sandwich. All right, so that's how we would count it out the long way. But all we need to do is take the 3 entrees that we have, the 3 sandwiches, multiply them by the 3 sides, and multiply that by the 3 drinks. And that would be the same as writing or 3 to the 3rd, which is equal to 27 outcomes of meals that we can make from the sandwiches, the sides, and the drinks. Let's look at another example. So another example would be that you're taking a test. It's a multiple choice test. So you know that there are 4 options: A, B, C, D, for 10 questions. You're not allowed to leave anything blank. And you know that there are 4 options with 1 correct answer per question. We want to select one of these 4 options or 4 choices for each question and leave nothing blank, like we're supposed to. In how many ways can we answer these questions, right? So we need to realize that there are 10 questions: 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now we know that there are 4 options for number 1, 4 for number 2, and so on all the way through 10. So all we have to do is multiply these together, right? So if we do, so that would be the same thing as 4 times 4, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that would be the same as 4 to the 10th, which is just equal to 1,048,576 outcomes of how many different ways we can do this. Okay, let's look at one more example. So the last example is we want to determine the sample space for flipping 3 coins. So when we flip a coin, we know that if we do flip once, this is an example, flip once, we're either going to get heads or tails. So there are 2 outcomes for this. When we flip 2, or the second flip number 2, we know that we're going to get heads or tails. So that's also 2 outcomes. When we flip the third, so first, second, flip the third, we're also going to get heads or tails, so we're going to get 2 outcomes for that as well. And what we need to do here, because we want to figure out what we would get if we flip, what can happen, what's the total amount that we can get for flipping all 3. So we would have to multiply 2 by 2 by 2. So 2 times 2 times 2, or 2 cubed, and that's going to give us 8. So that would be our total sample size for flipping a coin 3 times.